Okay, so let's get started here. A little bit different than yesterday because we're looking at difference of squares. Difference is subtraction. Ikema, pay attention. Difference is subtraction. So what's different is that we're going to have binomials, two terms. Okay. So we're going to have something like x squared minus 9. What happens is you square root the first term. That equals x. And so that will go at the front. Then you square root the second term, which equals y. That goes at the back. And the hardest part is the plus minus. Okay. So if we have x squared minus 9, we square root the front. Square root the front to give us x. And we square root the back to give us 3. And the hardest part, plus minus. Okay. So when we draw the diagram, because it's a subtraction, we are going to have 0 pairs formed. And instead of having x squared plus 2x minus 2x plus minus 4 squared, what happens is that these two combine and they are gone. So that's a 0 pair. And that's why we go from a normal trinomial to a simple binomial. Okay. So again, if we have x squared and we square root it, you get the answer to the front. If you have square root 4, the answer to the back. Okay. So let's look at this next one. Let's draw it. Please arrange your tiles properly. We're looking for perfect squares. Notice in above drawing, the ones tiles were a perfect square, and even the shape of the entire rectangle is a perfect square. So that means we have to have 4 squares here in this arrangement as a square, and our -1 goes here. It always must be a subtraction. Okay. So, complete the diagram. Go. Okay, so these are the x tiles, but in order to have 0 pairs, one set has to be shaded. So you can either shade the vertical ones or the horizontal ones. Then your answer, you must have shading on that particular one tile, and the other one will be unshaded. So we square root 4x squared, that is 2x at the front of each set of brackets. And we square root the 1, and yes, square root of 1 is 1. It's kind of special. Okay? A lot of you forget that. The square root of 1 does equal 1. And this one equals 2x. What's the hardest part? Plus, minus. Okay, they must be opposite signs. Okay, let's try some. Factor this one. Square root the first. And square root the second. What's the hardest part? Plus minus. Okay. So let's try the next one. What's the square root of 6? Don't use a calculator. What is it? Doesn't work, does it? Well, square root of 150? Doesn't work either. So what should we try first then? GCF first. Okay. They're both even numbers. You know there's going to be at least a GCF of 2. I bet you there might be a GCF of a higher number. 3. So 2 works, 3 works. 6 will work for both as well then. Okay, go ahead. Take out a GCF of 6. Okay. Now you should go and factor again. So you can see sometimes you got to factor more than once. You have to factor your factors. Hard. Good. X plus 5 and x minus 5. Golden. Okay, next one, number 3. What do you notice about 32 and 98? What kind of numbers are they? Both even. So you can divide by 2, but you can divide by 4. What do you guys think? 98 can't be divided by 4? You're right. So the highest GCF would be what? 2, and what about your letters? 2m. Okay, so go ahead, factor this as far as you can go. So we should get 2m, 4m plus 7, 4m minus 7. Hands up if you got that. Good. Okay, so we square root 16m squared. That equals 4m, and square root 49. That equals 7. Okay. Okay, next one. It's a race. See who gets the answer first. Go. That's why it's a little weird. Okay, this must be a subtraction, and so this is not a difference of squares. It is also not a GCF, so your answer is not factorable. If you leave the question blank, I mark it wrong. If you put down not factorable, I'll mark it right. I know, ha ha ha. You're only going to see this like once, maybe. That's it. Maybe. So don't write not factorable for every question, hoping you get that 1 mark. Okay? Oh, you laugh. I've seen some people write down like 10 times. Yes, Jamie? Yeah, but check GCF first. It's shorter. Hello. Okay, so what was it? Did you answer your question or not? 50 minutes? I'm going home. Yeah. No. 5-0. Okay, next one. What's different about the next one? Yeah, it's 2 different letters, okay? So a lot of you, though, you got to be careful here. You might think it's like 12y and 9z plus minus. But what do you notice about the 12 and the 9? You can take out a 3 from each of them, right? So originally you could take out a 9, I believe. Is that right? No, 3, no. Can you take out a 9 from 144? Yep. Okay, so take out a 9 first. So sometimes you'll notice you have to take out a GCF first. And you get 16y squared minus 9z squared. And then you're going to get the 4y plus 3z times 4y minus 3z. Okay? 6. Go ahead, do 6 now. This one you got to factor until you can factor no more. So you should be able to factor your factors. Go. Okay, this is not your answer. Why isn't it your answer? Because this is not done yet. You can do a difference of squares one more time. Go. So 3x plus 2 times 3x minus 2. How many different factors there? 3. Right? Here's 1, 2, 3 different factors. Questions? Yep. What's in the middle? Plus. Okay, so watch out for that plus, because it's super tempting, isn't it? Right? You're like, 9 and 4, I know that. Yeah. But you got to watch out for that plus sign. Okay? All right, any other questions? Okay, number 7, you guys work on number 7. Factor as much as you can. It's going to be one of those sum product ones. I'm going to fool around with question number 8, which would be like an honors one bonus, okay? What's the answer for the first part? What's the answer? ANSWER. Oh, you were talking, not working? Yep. A squared minus 16, a squared minus 1. So we start with an A4. That means the factors of A2, a squared. But what do you notice about each factor? You can factor again. Go ahead, factor one more time. So this one will have 4 factors. Okay, so here we have a plus 4, a minus 4, a plus 1, a minus 1. How many factors? 4. Okay. All right, so that's the end of difference of squares. Now we're going to look at perfect squares. So perfect squares. How we get a perfect square is the front term is squared. The back term is squared. To figure out the middle, you multiply together. 7 times a, 7a, and then you double it. What's 7 times 2? 14a. Pretty cool trick, eh? So now we got a squared plus 14a plus 49. So what happens is the reason why we double it is because when we do our multiplication with these two, we're going to get 7a plus 7a. There's 2 of them, so we've got to double it in the middle. Okay. So, write this out the long way, a plus b times a plus b. Now you're welcome to do all the long way, but the shortcut would be a squared, b squared. Now for the middle term, what's a times b? ab. And then times that by 2. Not squared, just 2 of them, 2ab. Now we have a negative sign. So you're welcome to do it the long way, but the shortcut says square the front, square the back. Now what happens if you multiply a times negative b? Negative ab. And then times that by 2? Negative 2ab. Also notice it's always a positive sign. No matter what, in front of that last term should be a positive sign. Okay. So you algebraically will have a squared plus 10a plus 25. I want you to factor that. So square root the a squared. What do you get? a. Square root the 25, what do you get? 5. Now what we have to do is divide this one by 2. What do we get? 5a. So what you must get is you must get both parts, right? You must have a 5 and you must have an a. Then you know you have a perfect square. Okay, so you must get 5a. Questions before we go on? Okay, right now I want you to turn the person beside you, explain how we get the middle term, and explain how we work backwards. Go. Back to learning. Let's go backwards and test out your theories. So, we want to say which of them are perfect squares. If not perfect square, why not? So can we square root m squared? Yeah, it equals m. Can we square root negative 25? No. Because of the negative sign, it's not a perfect square. For a perfect square, if you look up above, this one had a plus sign, and we had a plus sign. This one had a minus sign, but we're always getting a plus sign right there for the last term. Okay? So therefore, this is not a perfect square because you can't take a negative 25 and square root. Next one. Square root 4x squared, what do you get? 2x. Square root 9, what do you get? 3. What's 3 times 2x? 6x. Now if we divide this by 2, what do we get? Negative 6x. Can we somehow get these the same? What can we do to the 2x or the 3? Make this negative. What's negative 3 times negative 3? Still plus 9, which is the same. Okay, so yes, this one is a perfect square. There's your factors. 2x minus 3. Okay, now it's negative 6x. Okay, next one. Can you square root 4a squared? Yeah, what does that equal? 2a. Square root 16? You get 4. What about divide 8a by 2? What do you get? 4a. Do we have a problem here? Well, what if you multiply those together? How many a's should you get? And then double it, what would you get? Yeah, so it's not a perfect square. And that's because the middle term isn't correct for it. Okay. Try the next one. Do the letters make sense? X and a y, are they in the right order? Yeah, right. X squared, y squared, xy in the middle. Good. Can we square root 49? Yep, 7x. Square root 25? Yep, 5y. What happens if you multiply those together? 12xy, then double it. Sorry, 12xy, stand by 1. What's 5 times 7? 35. And then double it. We get 70, but we want negative 70. Can we get that somehow? What does our 5y have to be? Negative. So this one will be 7x minus 5y squared. Okay. So you got to be a little bit detective. If you don't get too wrapped up in perfect square, it's good to recognize the pattern. Makes factoring easier. But you don't have to be 100% expert in it. You can kind of work things out. Okay? Homework. Get it done. And I think you want to catch up on what you missed yesterday.